Okay, so now what we're going to do is we've looked at density, we've looked at pressure. Now we want to look at what happens when we have fluids that are flowing through, say, a pipe or a certain area. How do we calculate how much volume of fluids is passing a certain point? So volume flow rate is the volume per second of a fluid flow. So let's just say we had water going through a pipe. We want a way of measuring what volume of water is passing through this pipe. And the formula for that, here's where things you got to pay attention to. Are we looking at uppercase letters or lowercase letters? So this is a lowercase q with a subscript v. This represents volume flow rate. And the way that we figure out how much flow is happening, we take the total volume, so this is a capital V, divided by the time. So how much, this makes sense, right? How much volume of water is passing a certain point every second? And that volume flow rate is a lowercase q with a v representing that. We have three variables, so I can show you what a magic triangle looks like for this. And we end up with v up here, t down here, and qv over here. Okay, and we're taking volume. Now remember, volume is a little bit different than area. Area was just the surface or outer surface of something. Volume is actually how much space is occupied in a three-dimensional space. So if we had used that same, to get the area of this, we just did length times width. But if it's, let's say, a full box, we want to know, well, how much matter makes up this entire box? Now we're looking at a volume calculation, which is length times width times height. And if you think about that, length times width times height is meters times meters times meters. And you end up with something called a meters cubed, meaning that you took 3 meters and multiplied them. Okay, so that's what our volume is always going to be in meters cubed. Our flow rate, and we're dividing it by seconds, so our flow rate is meters cubed per second. We can look at an example. The volume flow rate needed to cut a metal component. So a lot of times in industry, especially working with automotive type parts, they'll actually cut metal with high pressure fluids. And so the volume flow rate needed to cut a metal component is 3.3 liters per minute. And the time interval required is 18 seconds. So we've got our time is 18 seconds. Calculate the total volume of water used during this process. So what they want us to find is V. What's the total volume of water? But what they've given us is the flow rate, and that is not exactly in the units we need. So 3.3 liters every minute per minute is the same as saying, if we want to convert this to seconds, 3.3 liters per every 60 seconds. And so what we end up with is 0.055 liters per second. And if we put it into our formula, if we go back to our magic triangle, we're solving for V, or volume. Cover up this V, and it tells us that we're going to multiply QV times T. So V is equal to QV multiplied by T. And we end up with 0.055 times time, which was 18 seconds, and we end up with a total volume of 0.99 liters. So that's the total volume needed to cut this metal component. Okay, and remember, I think I told you that our units are meters cubed. Another way of looking at liquid volumes sometimes is liters. Okay, and there's a conversion for that, but don't worry about that. Use whatever units your textbook gives you, and I'll try to guide you along the way with that. Okay, and then the final thing we're going to look at is basically the speed of the water jet can also be found from following a formula if we know the cross-sectional area of a pipe. So if we know the cross-sectional area of a pipe, so let's just say we've got a pipe. Pipes are generally round when you cut them in right through. When they say cross-sectional area, if you cut a pipe in half, you're going to notice if you look at it, the very end of it, it's usually a circle. And we've got water flowing through here. This is just another way of solving the exact same thing depending on what's given to you. So this is a way of doing it if we know it's a circular pipe and we want to know the area of that end. That's what they're looking at. And so if we have that information, Velocity, or the speed of the fluid, is a lowercase v, and now your textbook will usually do something like this. You'll use cursive. So this is a lowercase v is equal to our volume flow rate divided by the area. So again, it's just another way using different variables of finding the same thing if you had to. And because there's 3 variables here, we have a magic triangle. For this one, the QV goes up here, area down here, and velocity down here. Velocity, or your speed of the fluid, is meters per second, how fast it's traveling. Volume flow rate, again, is liters per second, or meters cubed per second. And our area is the area of the end of our pipe, which is usually going to be circular. So I'll show you what a calculation like that looks like. Calculate the speed of water, so we're looking for V, in a pipe of radius. So they're giving us the radius of the pipe. So if we were to cut this pipe in half, and the end of the pipe's going to look like this, the radius is half the distance across the center. This is the radius. And remember that the area for a circle is pi r squared. Okay, so they're telling us that the radius is 0.21 millimeters, and we have to convert our millimeters to meters. So you need to know that millimeters to meters is dividing by 1,000. And so we end up with 0.00021 meters. That's the same radius as what it is in millimeters. And our volume flow rate is 6.0 times 10 to the negative 6. That's given to us in our calculation, meters cubed per second. So we have our radius and we have our volume flow rate. What they're looking for is our V, lowercase v. Well, the only formula we have to use is this formula here. So V is equal to volume flow rate divided by area. Okay, so we don't have the area yet. We have to find out what that area is using the radius. So remember I said the area of a circle is given by pi r squared. So we end up with pi, if you have a pi key on your calculator, otherwise it's 3.14 approximately, times 0.00021 squared. So what you're going to want to do is square this number first, or multiply it by itself, then multiply it by 3.14. And what we end up with is a really small number, 1.385 times 10 to the negative 7. Now what you might guys want to do right now is try putting this in your calculator and making sure you can get to this answer, because when we're dealing with really, really small numbers, your answer might be given to you in scientific notation. And so you need to know what that looks like on your calculator, because every calculator is a little bit different. And so what we end up with for the area is this really small number. So that's what goes here. So our volume flow rate is 6.0 times 10 to the negative 6 divided by our area, which we just found, 1.385 times 10 to the negative 7. And our final answer, when we put that into our calculator, is 43 meters per second. That's how fast the water's traveling. Okay, so that's just 2 different ways of using similar variables to get different answers depending on the type of volume flow rate it is and depending on the type of information that's given to you. So you can only use this formula if you know that you're using a circular pipe and you know that you can calculate the area of that cross section. That's the only time you can use that. And that's it. So you guys are going to have a few practice questions and then an assignment to hand in.